Yeah, sure. Now you see here the turning of a plane. So when the plane banks or tilts to one side, as you see, the lift creates a horizontal component to one side, and similarly, the weight also has a horizontal component to the other side. Since ideally lift is greater than weight, therefore we can expect the horizontal component on that side to be greater. So we get the centripetal force required for the turning of the plane. So that is one of the uses of lift. Lift is one of the main things that engineers keep in mind while designing airfoils. You might be thinking what an airfoil is. That is an airfoil. Now you might say that is a teardrop shaped structure. It is a thing that you see in the wings of airplanes. You know, when you see the cross section, you will see something like this. That is the leading edge, this is the trailing edge, and the straight line connecting it is called the chord. The angle between the chord and the direction of flow of fluid is called the angle of attack. And the curved line which lies somewhat midway between the upper and lower surface is called the mean camber line. So if we go back to the concept of lift, it is basically, as we said, an upward force. Now, as to the reason of why lift occurs, it is a complex answer. But I would like to go with one principle that explains it very well, with somewhat help of Bernoulli's principle. So, if I were to look at lift, what happens is, as you see, when the air reaches the wing, at that point, it seems to break off into two branches. It is called the stagnation point. As you see, the upper branch has a greater velocity than the lower branch. What is happening is that due to centripetal acceleration, the upper branch gets accelerated more than the lower branch. Since the upper branch has a higher velocity, by Bernoulli's principle, we can say that there is a lower pressure above, which our previous group also explained using the equation of continuity. So therefore, there is a lift experienced by the flight as the pressure below the surface becomes more. Now, since we're talking about lift is not just the necessary thing. We also need a lot of thrust to fly such heavy aircrafts. So Samim, could you tell about the role of thrust here?
Yes, sure. Thank you. Now we shall be discussing about thrust. So basically thrust is a forward propelling force which takes the aircraft further in the air. Now what exactly is thrust? So it is a mechanical force generated by the engines of the aircraft. How? Now most oftenly it is done through a reaction of accelerating a mass of gas. Now the engine does work on the gas, further pushing it to the rear direction of the aircraft, as a result of which the engine is propelled further. Now this creates an impact or force inside the aircraft. Now how is it sustained by the aircraft or how does the aircraft defend itself against it? Now that depends on how well balanced the aircraft is. Now there are also many other factors attached to it, such as here we can see there is a diagram regarding the propeller. Now what is a propeller? It is basically a spinning airfoil. Spinning propeller produces thrust. The first successful aircraft propeller was indeed designed by Wright brothers. Now let's continue with the discussion regarding drag and other forces.
Just like movies are villains, drag is our villain here. A quick question for you all. Out of these three figures, which one would you expect to have the maximum drag? How many of you go with the first one? Okay, few hands. How many of you go with the steer? And how many of you go with the airfoil? I see more hands for the airfoil. I think I might have asked the wrong question. It's actually the flat plate. I asked for the maximum drag. An airfoil is designed optimally to reduce drag actually. Okay, no problem. Since I haven't already told about drag is like air resistance. It is the friction that is given by the medium. If there is no medium, there will be no drag. Now what happens is that when the medium applies a force on the solid, it is in a diagonal direction. If we resolve its components, we get a horizontal component which is the drag and the vertical component which is called the lift. And by designing airfoils, we have to keep in mind to maximize lift and minimize drag. Therefore, airfoils are streamlined. As you can see over there, the second image, airfoils are streamlined so as to create less turbulence, and also they ensure that they keep the angle of attack at a certain value, so that it provides a more streamlined flow, as I was telling, more angle of attack as well as a little bit of a positive camber line. So that's about drag. But is drag the only thing that is restricting aviation? No. There is also the concept of turbulence, which Sunandan will throw more light on.
Nandini.
So once Warner Heisenberg.
So these three control structures work together to provide more stability and ensure maneuvers in all directions for the plane.
Now, before wrapping up our discussion, we would just like to briefly demonstrate the flight of 3 planes that we have designed with paper, and will also help you to reinvent some memories of your childhood. Like here we can see it is a perfectly streamlined plane, so it can glide through the air if launched correctly. Now, KPS.
Now this one is a faulty airplane actually, and I have made it so that it spirals around. So let's see what happens when we make the wrong mistakes, So yeah, so a plane should not just come back, but it is in a turning around. So it's basically a boomerang plane. Mistakes gone right, I guess.
So here is a spinning.
Come to the end of our presentation.
We found it informative. Thank